This is a literature review for CAS 703. The article I am reviewing is Grand Challenges in Model-Driven Engineering, Analysis of the State of the Research. Some background. The article is authored by Bucaron, Cabot, Page, and Pierantonio. It was part of the Software and Systems Modeling Journal in January 2020. It focuses on model-driven engineering, and the article reports on the results of two MDE events that brought together experts from industry, academia, and the open source community to assess what has changed in research in MDE over the last 10 years, what challenges remain, and what new challenges have arisen. The two events were the Grand Challenges in MDE Workshop and the Winter Modeling Meeting. Some key points to note about this article. As mentioned, the State of Research article is based on assessment done by MDE community members for the benefit of the community. It is an aggregation of knowledge and ideas from experts in the field. The article, as we will see in the next slides, informs the reader of the evolution of challenges in MDE, as well as notes the benefits that have come from research in this field. It provides a snapshot of the current challenges in the field as discussed in the MDE community events, and it categorized these challenges for better understanding and navigation. Most importantly, in my opinion, the article introduces ideas to guide research and development in addressing these current challenges and potential future challenges in the field. The article begins by analyzing past challenges, splitting this up into pre- and post-2007 challenges. Pre-2007 challenges. This period was dominated by modeling language issues. UML was undergoing significant changes to semantics, infrastructure, and superstructure. Semantics of modeling languages and meta-modeling processes were in focus. Some key papers, such as the UML as a formal modeling notation by Evans et al., discussed the semantics of the language and motivated new approaches to formalizing it. Evans and Kent further described work currently undertaken by the Precise UML group to address UML semantics issues in their work Core Meta-Modeling Semantics of UML, the PUML approach. It included a focus on core elements of UML and its architecture, including generalization and packages. Evans et al. Further work on outlining a formalization strategy for making precise the core semantics of UML in their paper Meta-Modeling Semantics of UML. And Storl and Hausman's work reflecting on investigating how strong the alignment of UML's activity diagrams is to Petri nets in UML 2.0 in their paper Towards a Formal Semantics of UML 2.0 Activities were also noted in the State of Research article. An important point here is that the key use case at this time for modeling was code generation. This period of substantial effort and standardization led to the production of the following. Meta Object Facility, which is an object management group meta-modeling and metadata repository standard. Model-driven architecture, object constraint language, and query view transformation, which is a standard for expressing transformations specified by the object management group. Post-2007, according to the article, various research roadmaps identified a variety of significant research challenges, many of which have seen substantial research effort. Some of these issues are language engineering, principles, practices, and patterns for specifying abstract and concrete syntax. Lamlow's book, Software Language, Syntax, Semantics, and Metaprogramming is noted as a source for reflecting on this past challenge. Language workbenches, which are tools for defining and composing domain-specific languages. Some of these are JetBrains MPS, Xtext, Permeta, Racket, and SpoofX. Model management, processes for and tasks for manipulating and analyzing models, have seen significant research that has led to great theoretical and technical contribution. Model analysis, understanding what makes a good model and techniques for model analysis. The work of Moreno and Merce entitled Model-Driven Performance Analysis is noted in the article. Models at runtime. According to the article, this refers to the use of models to manage and understand systems after they have been deployed and as they execute. The article notes that this challenge is at the intersection of modeling and artificial intelligence research. Modeling repositories. Decentral locations for modeling artifacts were needed to support research and development. And scalability across different dimensions was addressed, since there was a demand for infrastructure support for working with large models. Active research in these areas continues. Here we have a graphic of the classification of current challenges presented in the article. As we see, the article addresses foundation, domain, tool, and social and community challenges. This article goes on to describe the technical challenges discussed at both MDE events. They are split up into foundation, domain, and tool challenges. Regarding foundation challenges, according to the article, this includes all the challenges concerning conceptual and theoretical aspects of MDE, covering all phases of software development. The support for long-lived legacy models is noted as a challenge. Allowing legacy models to coexist with modern technologies will help companies exploit proven valuable practices. There is a need to improve MDE solutions to support multidisciplinary and heterogeneous environments. Thus, proper model management is an increasingly pressing challenge. Software engineers need to perform as systems engineers that integrate different types of models on a system. Design uncertainty and conflicting stakeholder opinions need to be taken into account when developing systems. The article suggests that increasing software agility in MDE will improve system management. Extending MDE techniques will help automate maintenance solutions, and exploiting artificial intelligence techniques can help with maintaining complex systems. The adoption of new technologies requires skills that current professionals may not have, This requires an investment in developing the skills of practitioners, and it would be prudent to increase the usability and learnability of new technologies. The article also notes the challenge of bidirectionality in model transformations, which the article notes permits two or more models to remain consistent while they undergo modifications. This challenge is due to difficulties in assuring that a transaction is deterministic. The article then dives into domain challenges. This includes all the challenges related to application domains of systems developed using MDE. Assurance case modeling is an important part of model-driven engineering techniques to reduce risks and ensure software reliability. This area of MDE develops along with domains that it services. Modeling frameworks that support the integration of heterogeneous artifacts, such as data from sensors, engineering models, and new and changing regulations, are constantly in development. MDE will continue to play a role in development of the Internet of Things. As this domain develops, the MDE field will also need to grow with it. Lastly, MDE takes into account different system aspects and stakeholders. Different views allow for the separation of concerns, and they reduce the complexity of dealing with complex systems. In this regard, various engineering process disciplines have emerged and are being considered in MDE. Tool and implementation challenges. Lack of good tooling is mentioned in the article as one key aspect hampering the adoption of MDE. They mention that there's lots of good visual editors and visualization frameworks available, and that these help with working with complex problems. However, difficulties regarding their use are encountered. They suggest that further analysis regarding where current frameworks and tools fall short is needed. Complex systems are described using different heterogeneous views. Correspondence among these artifacts needs to be considered, especially when these artifacts span several stakeholders. In this context, expressing requirements in a human-readable notation that is also understood by a computer program is of high importance. Scalability is noted as a challenge in model-driven engineering. The problem is the size of the models and the diversity of artifacts. There is a need to tame the complexity of model-driven engineering. The article notes the need to work on the problem of running large transformations, running them on large models, as well as parallel and incremental querying and transformations. Specifically, the article references the work of Budding et al. On understanding and modeling complex artifact relations titled On the Need for Artifact Models and Model-Driven Engineering Systems projects. Additionally, it was noted that many core MDE aspects can be improved alongside the simplification of the creation of improved tool support for executable languages, including by providing various analysis tools for executable domain-specific modeling languages. The idea was taken from the work of Mayhover and Combler in their paper, The Tool Generation Challenge for Executable Domain-Specific Modeling Languages. Lastly, the article noted that MDE tools should become more intelligent and autonomous by adopting AI techniques. Citing a paper by Garcia Dominguez and Bencomo, more MDE tools need to collaborate on how to manage and evolve models according to a shared list of goals. Bill et al. Further add that timing issues will be a major concern in this regard in the paper on the need for temporal model repositories. Finally, the article covers societal and community challenges, which it notes are important considerations in order to be able to validate technical solutions. Regarding social challenges, the article first noted that MDE should be a catalyst to enable non-technical people to build the tools they need in their domains. They reference Kelly's paper titled Modeling by the People for the People, which argues that model-driven engineering research should be reaching out to make itself presentable to subject matter experts as opposed to strictly programmers. Along this line of thinking, the article further comments that stakeholders could be assisted in exploring the design space of potential models to be built, an idea which the article attributes to Konrari and Reddy. A suggested solution is the use of example-based modeling. The article also raised the question, how much modeling is enough, regarding bridging modeling with agile development approaches. The article also notes that the workshops on which it is based considered whether reluctance to employ MDE tools might be related to concerns over intellectual property of the resulting models, and offered that adopting well-known intellectual property management techniques to MDE artifacts may prove to be a way to alleviate this concern. A final suggestion regarding social aspects was the suggestion of moving to domain-specific MDE. As domains require differing solutions, tools could be explicitly tailored for different situations and for stakeholders in terms they understand. The article then moves on to comment the community aspects, noting first that the critical argument from the workshops was that researchers and practitioners of MDE have not succeeded in selling the benefits of MDE to the software development community, and that further educating the community on these benefits would be needed. The development of rich model and project repositories was also a need that was a consensus in the MDE community. Finally, they noted the issue of the difficulty of setting up MDE teaching environments and questioned how to teach the next generation of MDE practitioners, specifically whether to teach them how to use MDE tools or to build them. As far as contributions of the article, to summarize, the article notes the issues and challenges in MDE that were raised at the two events that brought together experts from the community. This is a contribution to the community since many practitioners and interested parties might not otherwise have access to these discussions, and it aggravates their ideas. Some of the issues have been identified by individual researchers and practitioners and are now making their way into conventional knowledge thanks to this article and the MDE community events that it reports on. The article presents these changes and challenges in MDE in a chronological and categorized order for better understanding of how the methodology has evolved over the years and how some of these challenges have developed. This contributes to a better understanding of the methodology and gives readers some foundational knowledge to better address the challenges. This thus contributes to stimulating researchers, practitioners, and developers to better advance the methodology. Regarding evaluation of the article, since this is an article that aggregates ideas, there was an evaluation of the article by the Software and Systems Modeling Journal prior to the publication. The ideas and points that are laid out in the article were formed by researchers, practitioners, and developers within the MDE community and were evaluated, highlighted, and aggregated by their peers. There was at least some consensus to their correctness from these experts. At these events, expert participants were encouraged to share their ideas, discuss their findings with fellow experts, and generally explore topics in MDE. In this way, the ideas presented in this article have been professionally evaluated. The ideas were then filtered by authors of these articles, who are also experts in the field prior to addition to the article. Ideas presented in this article, such as those regarding model representation and an increasing demand for improved MDE tool support and many others, have also already been cited by other academic works, such as Van den Heuvel and Tumbari's work, Model-Driven MLOps for Intelligent Enterprise Applications, Vision, Approach, and Challenges, and Musbacher et al.'s work titled Opportunities in Intelligent Modeling Assistance as examples. The veracity of these ideas has thus been further evaluated by experts in the field. Regarding influence of the article, although published only 1 year ago, the article has already had some impact on the field. As stated in the previous slide, it aggregated ideas surrounding challenges in the field as presented in these two events. These ideas from experts might not have had so much reach if they were not aggregated in the article. As we will see in the next page, the article was already referenced many times in its short life. It has helped MDE methodology experts further analyze the theory of software design, especially the challenges surrounding MDE. Some highlights of influence include research on domain-specific modeling language, specifically the work of Dalla and Ahmed titled The Sustainable Efficiency of Modeling, a Correspondence Undergraduate Transaction Framework by Using Generic Modeling Environment, proposing process for model-driven software development in spite of MDE challenges, specifically the work of Albura et al. Titled A Process Model for Component-Based Model-Driven Software Development, proposing new MDA approaches to application development, specifically the work of Pallone et al. Titled Automatic Code Generation of MVC Web Applications. They particularly cite this article for its comments regarding the usability of model transformation techniques. Adoption of model-based perspectives for systems of systems engineering, specifically the work of Boysen et al. Titled Digitalization in Next Generation C2, Research Agenda for Model-Based Engineering Perspectives. This work fairly significantly relies on this article. It cites the article for its comments on scalability issues regarding large-scale models, issues of capturing design alternatives from various stakeholders, and the challenges of current model-based technologies. Assessment of impact. As noted previously, the article was published in January 2020. In this short span of time, the article has been cited 25 times in scholarly literature. Looking at these citations closely, the article has been cited by several types of scholarly literature, including conference papers, research and journal articles, thesis papers, and one short paper. This scholarly research itself has already been cited 9 times. A better assessment of the full impact of the article can be made once more time has passed since its publication. So some limitations of the article. A strength of this article is how succinct it is in its presentation of ideas regarding the challenges in MDE. The article is easy to read and allows readers who are interested in MDE to quickly absorb some key information regarding these challenges. Although a subject of opinion, this can also be a limitation. Further detail about some ideas in the article, specifically regarding reference material, can be beneficial. For example, the work of Kovos et al. Titled A Research Roadmap Towards Achieving Scalability in Model-Driven Engineering is only noted in the article as a source for the idea that scalability is a main challenge in MDE. The article would, in my opinion, benefit from the direct addition of further details from this rich paper. Another limitation is that there are, in my opinion, some omitted ideas from some of the reference material. As an example, some MDE challenges that are presented in reference materials could be added into the article. Bencomo et al.'s article titled Models at Runtime, A Guided Tour of the State-of-the-Art and Research Challenges details many additional challenges surrounding runtime models that could, in my opinion, have been included in more detail in this article. Furthermore, several ideas were presented in the article that would benefit to include references to academic works. As an example, in the Domain Challenges section, the statement that regarding separation of concerns in megamodels, various engineering disciplines have emerged and are involved in the engineering process would benefit to include a reference so that the reader can become familiarized with these disciplines in this regard. Another example of where additional references would benefit this article is in the Foundation Challenges section. The idea of extending MDE techniques by exploiting AI techniques that nowadays are ready to be used for such complex and dynamic systems would also benefit to include a reference so that the reader can familiarize themselves with such AI techniques. In summary, based on expert opinion collected at 2 MDE events, the article identifies several challenges in the MDE field that are categorical in nature. The goal of the article is to stimulate researchers, practitioners, and developers to explore these issues and improve the field. As for future directions, we should look to address the challenges raised in this article. Some of these directions, as mentioned in the article, are: we can look to find ways to better connect discussion models with software artifacts, thereby alleviating uncertainty surrounding many design alternatives. We can develop MDE to better abstract machine learning technology. MDE could be applied in the development of IoT and smart systems technologies. continued development of visual editors and visualization frameworks to better aggregate data of complex models. Scalability solutions will also require further development. The increasing size and number of artifacts of complex projects has created complexity problems in modeling. These will need to be better aggregated in MDE development. Exploring the development of example-based modeling in order to enable non-technical people to build the tools they need in their domains is an interesting future direction to consider. Lastly, we can develop the large model repositories using community-based curation efforts is a practical direction that could fairly easily be attempted and implemented. Personally, this is the first direction that I would look to implement. I believe that this would have incredible impact on the model-driven engineering field and would incentivize the growth of new MDE community members. All of these are directions that have been suggested in the article to address various MDE challenges. I expect that at least some of them will be further research attempted and evaluated in the near future.